Welcome to calculus.
We've always been good at math. How hard could calculus be?
On this episode, Stevenson will demonstrate.
Find the volume of the solid generated by revolving the region about the given line. Now, we've seen this problem before, at least the same region and lines. However, this time, the line of revolution has changed. Now it is above the region. So let's apply what we learned in the previous example to this situation here. So the first thing, again, as we normally want to do, is we want to make sense of what we're seeing here. So we're going to take, here's our rectangle. Now again, with respect to the x-axis, so our thickness is dx. And we're going to rotate it around this axis, so notice it's above the region. Now there is a gap here, so we're still going to create a washer. So let's draw our washer. Now I know some of you are probably thinking, Stevenson, do we always have to draw the washer? Not really, but if it helps you to visualize what's going on, I highly recommend it. Alright, so we need to know what's our big R and what is our little r. Remember, the big R represents the outermost radius. So in this case, the outermost radius is going to be that distance. It's actually going to be the linear function because it's the farthest away from our axis of rotation. So let's talk distance. So what is that total distance? Well, I know the distance from the x-axis to the line is 7. Well, that's easy, so that's just 7. Now we're going to add the distance from the x-axis to the line below. Well, that's just going to be 2x. What's the inner radius? Let's think about this. The inner radius is going to be that distance there. Now again, how do I know that? Well, the inner radius is the function that is closest to your axis of rotation. How are we going to represent that distance? Well, we know the total distance from the x-axis to the line of rotation is 7. And we know this distance from the x-axis to the sine function is sine. So if we take that distance away, then we get the distance left over. Remember, we applied that same idea in the previous problem. So essentially, these are our two radiuses, or radii. So what is the volume of a single slice? So remember, the volume of a single slice is pi, and it's the big radius squared minus the little radius squared dx. Now again, it's dx because we are integrating with respect to the x-axis. So what is going to now be the volume of the total object though? So we're going to do the integral. Now, because it's with respect to the x-axis, we are integrating again horizontally. So we're going from 0 to 2 of all of those little slices there. At this point, with this kind of problem here, I would just go straight to your calculator if you need to actually calculate an answer.